So today we are going to learn about the tricks on how to memorize Maxwell relation in thermodynamics, since this is the most common question to be asked in our exam. So this is the most confusing topic in thermodynamics. So we can memorize this by making mnemonics. So I have made a mnemonics to memorize this. First of all, after finding out the general Maxwell relation, we have to let different variables in the place of x and y in a serial wise manner. First we will let s instead of x, and then v instead of y, and then these written variables respectively. Then the result will come is will be like this. So I'm writing here the mnemonics. The mnemonics is Sachin Tendulkar and Sara Tendulkar have a very vibrant and powerful pitch. So the mnemonics for the result is that is the school teacher and students play piano and violin very nicely. The school teacher and student play piano and violin very nicely. So here I have made a mnemonics and I have written it down. So here this is the mnemonics for letting the variables. Sachin Tendulkar and Sara Tendulkar has a very vibrant and powerful pitch, whereas the next one is the result. The school teacher and the student were playing piano and violin very nicely. So the next one is the result of the relation after putting the considered variables. So I have encircled the variables like s t, v, p, p. So it will seem like this. In x, if we let x equals to s and y equals to v, then we will get the Maxwell relation A. If we let x equals to t and y equals to v, we will get Maxwell relation B. If we let x equals to s, t, y equals to p, we will get Maxwell relation C. And if we let x equals to t and y equals to p, then we will get Maxwell relation D. So the result will seem like this. Maxwell relation will have t and p as variable. It will seem like this. Del t by del v. Maxwell relation equation A will seem like this. Del t by del v by del v, partial derivative of del t with respect to p, partial derivative of t with respect to v, keeping s constant, is equals to partial derivative of p with respect to s, keeping v constant. And this will be our Maxwell relation equation A. The equation first and last will have the minus sign, whereas the second and third will not have the minus sign. When we put x equals to t and y equals to v, x equals to t and y equals to v, then we will get this equation, and del p by del t, v equals to del s by del v t. So similarly for this for the third and fourth relation, this is easy. If we get confused about what to put on the denominator or numerator, then I will show you this like this. If we let x equals to t and y equals to p, then we will get from this a trick. We will get x equals to t and y equals to p, then we will get s and v as a result. So first of all, we have to write del s, and in the another side of equal to is del v, because this is on the we are letting the last we are doing it for the last equation. So it will here will be minus sign in front of alongside del v. So we have written del s equals to minus del v. So we know that del s has the relation with temperature, so it will come under as a denominator of del v. So del t will be here, and we will keep a bracket here. Then del s, we know that the volume has the relation with pressure, so del s will have the denominator as pressure, del p. So for the constant values, since s and p are already present, then t is the constant value, and since we have t as the denominator, so p will be the constant value.